day, everyone. My name is Adekuni. If this is your first time, do want to subscribe to this YouTube channel so that you can enjoy more resourceful tutorial videos. And I also advise that you like this video and comment on the video. If there's any question or anything that is looking unclear to you. So without wasting our time and without any hurdle, can we just dive into what we have for today? Today I'm going to be providing solutions to the assignments given to us some weeks ago. I'm talking about students of drillTutors. So I'm going to be providing solutions to those 50 questions now. I advise that you sit back, get your notes and your pen with you even as we go now. Follow me steadily, and if there's anything you feel you don't understand, you can always back the video till you get the point. So follow me as we go now. Before I have 50 questions given to us, I have 50 questions. Okay, the first question here says that find the square root of 4 plus 2 root 3. This is the topic under solve, and we call this exact problem, or this topic, we call it mixed quadratic solve. Mixed quadratic solve. So I want to find the square root of 4 plus 2 root 3. How do I go about it? That is the question. We call it mixed quadratic solve. So this is the sort of mixed quadratic solve. You were taught, for those who have been consistent in our classes, that whenever you have a solve or root of solve of the form a plus would be like this. If a and b satisfy these two conditions, that is, when a and b they are both positive, a and b are both positive or element of big numbers, and at the same time a squared minus b is a positive number, that is a non-negative number, then we can represent this this mixed quadratic solve in the form root x plus root y, where x and y are actually elements of positive big number union 0 like this. So x and y are elements of positive big number include with 0 inclusive, with 0 inclusive. So these two numbers here, what you can see here, actually satisfies the condition. So we want to express this in the form root x plus root y. And also we prefer the solution, to x and y. And we said that the value of x on comparison, when you square both sides and you solve x and y, you will get that x is equal to a plus the square root of a squared minus b all over 2. And you also find out that y is equal to a minus the square root of a squared minus b all over 2. So these are the solutions for x and y. Now I want to provide solution, I want to express this in this form. The answers will, of course, for x, we want everybody. That will be a. What is our a? Our a is 4 plus the square root of a squared. We said our a is what? Our a is 4. Which means that the square of 4 is what we give there. Minus b. Our b now, see what we have here. We have b. And inside this one, you have 2 root. So what you do is that you bring 2 inside into the root. And that gives you 3 times 4, which is 12. Telling you that the value of b is actually 12. All over what? All over 2. Which is the same thing as 4 plus root 16 minus 12, which is 4 all over 2. And that is what everyone. That is 4 plus 2 over over 2, which is simply 3. So the value of x is 3, and that of y is 4 minus the square root of a square. What is a square? We said a square is 4 squared minus 12 over 2, which is 4 minus the square root of 4 all over 2, which is 4 minus 2 over 2, and that is 2 over 2, which is simply y. Now, what does that tell you? That tells you that the solution to this is equal to the square root of x, which is 3, the square root of 3, plus the square root of 1, which is also the same thing as the square root of 3 plus 1. And of course, this can also be expressed as 1 plus root 3. Since addition is commutative. The second question says that find the square root of 8 minus root 15. Find the square root of 8 minus root 15. It satisfies the two conditions that a and b must be an element of real numbers, and a square minus b should be greater than 0, greater or equal to 0. Now, here we have a square minus b to be greater than 0. A square here is what? That's 64. Minus b, the value of b is 15. That is satisfied. And also a and b are element of real numbers. Now, the solution to this, we want to express it in the form the square root of x minus the square root of y. We said that when it is addition that is between them, the solution is the square root of x plus square root of y. And when it is subtraction, it is square root of x minus square root of y. So how do we solve this? The same process is applied. The value of x is a plus a square minus b all over 2, and y is a minus a square minus b all over 2. So our x here, everyone is what? That is a, which is 8, plus the square root of a square, which is 8 squared, minus b, which is 15, all divided by 2. And the value of y is simply 8 minus the square root of 8 squared minus 15 all over 2. This is simply 8 plus 64 minus 15 over 2, and this is 8 minus 64 over 2. And that is what? That is the same thing as 8 plus the square root of 49 over 2, and this is 8 minus the square root of 49 over 2. This is 8 plus 7 over 2, and this is 8 minus 7 over 2, and this is 15 over 2, and this is 1 over 2. And that is also expressible as 7 and a half, which is 7 number 1 over 2. So which implies that the solution to the mixed quadratic sort that we have here is the square root of 15 over 2 minus the square root of 1 over 2, which you can leave as that, or better still, you can just say, okay, 8 minus 15 is equal to the square root of 15 over 2 minus 1 over 2, which is virtually still the same thing. If you rationalize 1 over 2, you will get 2 over 2, so which is square root of 15 over 2. You can go to rationalize both of them. That will be minus what? Minus 2 over 2. If you want to rationalize this, that is simply root 15 over root 2 times root 2 over root 2. And that is what? That is root 8 over 2. And can root 30, is it possible for us to simplify that? That's simply saying that we have 2, we have 4, we have 9, none of them. So this is also the same thing as root 30 over 2 minus root 2 over 2. which is simply 30 minus 2 all over 2. So you can do the answer like that. Now, question 3. The third question says that prove that s squared minus 2s plus 4 is a factor of s cubed plus 8. So we want to prove that this is a factor of s cubed plus 8. You were taught a polynomial, what we call the factor theorem, factor and the remainder theorem. And we see that expression is a factor of a polynomial on the condition that the numerator is 0. I'm sure you remember, we said that if you have a polynomial this, or let us let me use f of x, which is of degree n, where n is greater than 1, of course, in Rs. And you have another expression or a quotient which will represent by this, which is of degree n minus 1, where n minus 1 is also in Rs. We were told that what we have here is expressible as f of x to be equal to q of x multiplied by x minus a plus r, where this guy is what we call the divisor. This is the quotient and this is the numerator. Where at the point where x is equal to a, that is when you have f of a, if the numerator you have is 0, then we say what we have, which is a linear factor, is actually a factor of the polynomial. But in this case, what we have is actually not linear. But still, we can still check if it is a factor of the polynomial by simply showing that the numerator is 0. So how do we do that? This is a non-division. I have f cubed plus 8 as the polynomial, and divide for is s squared minus 2x plus 4. Okay, let's divide. S squared, s cubed divided by s squared will give you x. And s squared times x is s cubed minus 2x times x minus 2x squared. And 4 times x is of course plus 4x. Subtracting the two expressions from each other will give you 2x squared minus 4x plus 8. 2x squared divided by s squared will give you plus 2. S squared times 2 will give you 2x squared. Minus 2x times 2 will give you minus 4x. And 4 times 2 will give you plus 8. Now, substituting the two expressions from each other actually gives you 0. Telling you that the remainder is simply 0. Which proves that s squared minus 2x plus 4 is a factor of s cubed plus 8. Now to the fourth question. The fourth question says that we should prove that A union B is equal to the difference of A and B union A intersection B union B minus A. I would have loved to actually skip this question because I expect everyone of us to know the answer, but I'll do all to explain how to go about it. How do you solve this? Let x be an element of what you have at the right hand side. You were told that whenever you want to prove the equality of sets, that is, we say that two sets A and B they are equal only on the condition that A is a subset of B and at the same time B is a subset of A. So in order for me to prove the equality between these two relations, I have to prove that each of them are subsets of each other. So how do we go about that? Let x be an element of A union B. If X is an element of A union B, it implies that X is an element of A or X is an element of B. So that is what that expression, that is the message it passes to us. That is the message we get from that. Now, let's deal with what we have on the right hand side. So I have here that X is an element of A or X is an element of B. Now, let X be an element of A minus B union A intersection B union B minus A, like this. In order for me to prove this, what we have here is simply the same thing as X being an element of A minus B, or X being an element of A intersection B, or X being an element of B minus A. Now, this implies that X is an element of A and X is not an element of B, or X is an element of A and X is an element of B, or X is an element of B and X is not an element of A. Now look at what we have here. Let me read that to you. I said that X is an element of A and X is not an element of B, or X is an element of A and X is an element of B at the same time, or X is an element of B and X is not an element of A. What does that tell us? That tells us that X is actually an element of A or X is an element of B. That is something to that. I don't want us to waste time writing on that. That is the message we get from that. It's either X is actually both A and B. So, which proves that X is actually an element of A and B. Which tells you that what you have on the right hand side is a subset of what we have on the left hand side. That actually proves that A union B is simply the same. Is equal to A minus B union A intersection B. Sorry about covering that. Union B minus A. And that is the solution to the fourth question. Also, I want to do something. I want to show that the relation is true. How do you show that the relation is true? Open this up, simplify it, and prove that what you have here is equal to A union B. I will really be expecting solution from you guys. That's the first assignment I have for you. Now, to the fifth question. To the fifth question. The fifth question says that compute the arguments of 1 plus I. So I want to find the argument of 1 plus I. One slide should let you know, let me take you back to what we've done before, is that we have what we call the geographical representation of complex numbers. And that is that it's a system that helps us to express or find the geographical representation of complex numbers. So what am I saying? When we talk about arguments, we're actually talking about the direction of complex numbers. Imagine the complex number from Z to be equal to A plus I. Now, how do we find the argument of this complex number? Argument argument is simply a system of graphical representation of complex numbers. The argument of Z has different values for different values of A and B. Now, the value of the argument of Z is the tan inverse of B over A when A is greater than 0. The value of the argument is tan inverse of B over A plus pi when A is less than 0. Using the Cartesian coordinate as point of reference, we have B and we have A here. When A is greater than 0 is on this side. When A is less than 0, we are talking about something on this side. But B is simply greater than 0. So when A is less than 0 and B is greater than 0, the value of the argument of Z is tan inverse of B over A plus pi. Now, the value of the argument of Z is tan inverse of B over A minus pi when A is less than 0, and at the same time B is also less than 0. So I don't know anything along this in this order. Now, the value of this argument of Z will be equal to pi over 2. Will be equal to pi over 2 at the point where A is equal to 0, but B is greater than 0. So when A is equal to 0 and B is greater than 0, B is on any of these. Takes any value, the value is pi over 2 is 90, and the value will be minus pi over 2 at the point where A is equal to 0 and B is less than 0. B is on this line, but A is equal to 0. So these are several values of the argument of Z for several values of A and B. We also have that when A is greater than 0 and B is equal to 0, and when A is less than 0 and B is equal to 0. Now let's work on the argument of 1 plus I. The argument of 1 plus I. The argument of 1 plus I. From what you see, A here is 1 and B is also 1. So that means that our A is greater than 0. Let me give that the argument of 1 plus I will be equal to tan inverse of 1 over 1, which is simply tan inverse of arctan of 1, and that is 5 over 4. That is the answer. Simple. Now to question 6. Now to question 6. Question 6 says that compute the argument of minus 1 minus I. We want to find the argument of minus 1 minus I. What do you see here? You see that A is less than 0 and B is also less than 0. Telling us that the value of the argument of this was simply the tan inverse of minus 1 over minus 1 minus pi, which is tan inverse of 1 minus pi, and that is simply pi over 4. Pi over 4 minus pi, and that is what? That is minus 3 pi over 4. That is the answer to question 6. Now to question 7. Question 7 says that calculate the argument of 1 over I raised to the power 50. We want to estimate and want to evaluate the arguments of what we have here. So how do we find the arguments of this? Let me just quickly rephrase this. In class, we were taught 3 different properties of arguments. The first is that whenever you have the argument of z1, the multiplication of 2 complex numbers in this form, this is also the same thing as the argument of z1 plus the argument of z2. And also the second is that the argument of z1 over z2 is the same thing as the argument or the argument of z1 minus the argument of z2. And the third one is that the argument of z1 raised to power n in this form is simply the same thing as n multiplied by the argument of z1. Now looking at this, I need to use 2 of these principles, and that is this and this. So the argument of 1 over I raised to power 50 is simply the same thing as the argument of 1 minus the argument of I raised to power 50. So now, of course, the argument of 1 tells you that A is greater than 0, but B is equal to 0. So at the point where A is greater than 0, that is along this line, but B is equal to 0, so it is 0. It is 0. It's not moving, it's on this line. So that is 0 minus, of course, using the third principle, I have minus 50 multiplied by the argument of I. The argument of I tells you that A is equal to 0, but B is greater than 1, which is pi over 2. And that is simply 0 minus 50 multiplied by pi over 2, which is the same thing as minus 25 pi. And that is the solution to the 7th question. That is the solution to the 7th question. Now to question 8. I want to calculate the arguments of 1 over 2 plus root 3 over 2I over minus 1 minus I. Like this. I'll find the arguments of this. Of course, the arguments of everything you have here is simply the same thing as the argument of 1 over 2 plus root 3 over 2I minus the argument of minus 1 minus I, like this. So we have this. And of course, what does this tell you? This is simply the same thing as this one here. You have A to be greater than 0. And what does that tell you? That is simply the same thing as tan inverse of 3 over 2 all over 1 over 2. Then minus tan inverse. At this very point, A is less than 0 and B is also less than 0, which is the third quadrant, and that is simply tan inverse of B, which is minus 1 over minus 1 minus pi. So this is the same thing as tan inverse of, if you evaluate that, that will give you tan inverse of root 3 minus tan inverse 1 minus 5. And this is, of course, tan inverse of root 3 minus tan inverse of 1 is pi over 4. So that is pi over 4 minus 5, which is 60 degrees. Pi over 3 minus what you have here is minus 3 over 4 pi. This is the same thing as pi over 3 plus 3 over 4 pi. And of course, that is 4 plus 9, 13 pi over 12. And that is the answer. And that is the end of today's class. I really hope you get something. If so, do want to like this video and also drop a comment, because that will go a long way. And if you are yet to subscribe, please subscribe. Please subscribe. Let's hit 200 subscribers after this very video. Thank you, and I will see you in my next video. Bye.